Hello friends, welcome to Susan and John MathTube. This is lesson number 6 in the exam preparation series for the second year engineering students. In this lesson, we continue to solve the linear programming problem or the LPP with the help of SIMPLEX method. And as always, the most important question and the answers, and I'll strongly recommend you follow the 5 points very seriously, because especially in SIMPLEX method you need a lot of practice. And with that, let's start the video. So we have a question, and that's also from 2073. So I hope you watched lesson number 5, in which we discussed SIMPLEX method, or rather the shortcut method for the SIMPLEX method. Okay, so let's start. Now, as I told you before, check the optimal function. Okay, I can see the word maximize. And now you check the inequations. Okay, good. Less than or equal to, less than or equal to. Now let's start the process. So there are two less than or equal to symbol which I can see. So I'm going to write, let the slack variables be S1 and S2. So what will happen to the first inequation? Yeah, it will be x1 plus 3x2 plus S1 is equal to 10. And the second one will be 2x1 plus x2 plus another slack variable is equal to 10. I told you how this becomes equation and all in the last lesson. And now what should we do with the optimal function? Yeah, you're right. We have to take everything to the left hand side. So we get minus 15x1 minus 10x2 and plus z equal to 0. Okay, now let's write the first SIMPLEX table, or rather in the shortcut I gave you, let's write the first SIMPLEX matrix. So if you want, you can write this. I told it's good. So I'm writing all the variables, basic and non-basic variables, and the objective function and the right hand side. And let's put a small break here. Okay, so let's start writing. Yeah, so here we go. So we get 1, 3, 1, 0, 0, and the right hand side is 10. And then we have 2, 1, 0, 1, 0, and the right hand side is again 10. You can check this. You can check this. 2, 1. There is no S1, so 0, then again S2, 1 and 0, the right side is 10. And the objective function, that is minus 15 minus 10 0 0 1 0. Okay, now what should we do first? We have to find the most useful variable, and that means the most negative variable. The most negative number. And then we declare this is the pivot column. Now what we do is we find the pivot row. So we write ratio. You can do this outside the matrix. So 10 by 1, you can circle it, 10 by 2, 5. It's obvious. You take the least positive quantity. I'll repeat, we take the least positive quantity. Now you may have a few doubts in the exam. What to do if you get the same number, like what you call the least numbers being the same? That means you can choose any row you like. Second question, what will you do if you get negative or infinity, etc., etc.? The answer is just ignore them. Just ignore such rows. And now one more very important thing, what will you do if everything turns out to be negative? If everything turns out to be negative, it means the solution is unbounded. So remember, this is something very, 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 very important. If all the values are negative, it means we have unbounded solution, or rather we cannot solve. Okay, so this is the pivot column, and then we found this least element, and the element which coincides is the pivot element. Now what we do is we try to make this element 1. So you can see the 3 rows R1, R2, R3. So we do R2 changes to R2 times 1 by 2. And that is exactly what we are going to write here. Okay, so when we do that R2 changes to R2 into 1 by 2, I hope you did these things by yourself. So we got 1, 1 by 2, etc., etc. Now the next thing to do is you have to make the element just above and just beneath this 1 into zeros. So I'm going to write the operation here. Our target is in the first row. So R1 changes to R1 minus R2. And then our target is in the third row. So we write R3 changes to R3 plus 15 R2. So we get something like this. So the first row is going to change, and that's pretty easy. R1 minus R2. So 1 minus 1, that's going to be 0. And 3 minus 1 by 2, that is 5 by 2. And then 1, and then minus 1 by 2. And then 0, and then F5. And now the same thing. So I'll use a different color. So there is no change over here. And 5. And then let's put that divider. And then the third row is also going to change. Minus 15 plus 15, that is 0. Minus 10 plus 15 by 2, that is minus 5 by 2. And 0, and then 0 plus 15 by 2. And then 1, and then 0 plus 15 into 5, that is 75. Okay, now the sad news. Is this optimal? No. That means you're going to do more work. So I identified the pivot column. So this is our pivot column. Now here you can write ratio. And what you do is you find 5 by 5 by 2, and that is equal to 2. You can circle that. Then so we get 5. So the least value is 2. So this is our pivot element. So I hope you understood that part clearly. So the next operation is we have to make this pivot into 1. We must make the pivot element into 1. So the target is in the first row. So R1 changes to R1 into reciprocal of 5 by 2. So we get 0, 1, 2 by 5, and minus 1 by 5, 0, and 2. And the remaining will be the same. So we get 1, 1 by 2, 0, 1 by 2, 0, 5. And if you want, you can use a divider, but there's no difference. So I'm just copying the same thing, 1 and a 75. So we found the pivot, and we made the pivot element 1. Now our aim is to make all the elements beneath and above, but there is no one above this 1, to 0. So our target is in the second row. So I'm going to write R2 changes to R2 minus 1 by 2 R1. And R3 changes to R3 plus 5 by 2 R1. And that gives me, okay, there will be no change over here. So we're going to get the same thing. The same thing. You just copy the same thing over here. And 1 minus 0, that is 1. And that will be 0, of course. That is how we designed it. And that is minus 1 by 5. 3 by 5, 0, 4. Because 5 minus 1, that will be 4. And let's put the divider. 0, 0, 1, 7, 1, 80. Okay, now that's Really good because it's the last step. You look at this row, all the numbers are positive, and that implies the table is, or the matrix is, optimal. Okay, now what should we do? We have to find the identity columns, or the columns in the identity matrix. The identity matrix over here is 1 0 0 1, and you should search for 1 0 and 0 1. Okay, I already found it. 1 0 I found here, and 0 1 I found here. Now look at this. In the first step, we put the variables here: x1, x2, s1, s2, z, right? So now what I do is I write the same thing: x1, x2, x1. No need to write the others because it's enough to write above the identity columns. Now you go a little bit beneath, meet Mr. 1, and go to this side and write x1. And here also you go to Mr. 1 and move to this end and write x2. Now you circle this x2 and move this end to the right hand side. Okay, that is x2 is equal to 2. So we found one thing, and again you do the same thing. So x1 equal to 4, and you can put these things in the objective function. You'll get the maximum value, but if you want the value right away, you can just focus on this. So the optimal value for z is equal to 8080. So let's try one more question so that the method becomes even better. So please write the question. I'll repeat one more thing. In Simplex, if you want to be really successful in the exam, then you must practice at least 15 questions. If you are able to solve 15 questions by yourself, then congrats, you will definitely do Simplex within a few minutes in the exam itself. And normally they ask Simplex method for 10 marks. And recently the trend is they started asking BIGAM method. And maybe they might even ask two-phase method. So there are total 4 methods. One is the graphical method, which you started learning in class 10, and then you might have learned in class 12 if you took what you call group C, and the same thing you learn in engineering, that is graphical method. And the second method is Simplex method, that is exactly what we are learning now. And they used to ask Simplex method for 10 marks. But recently, they started asking something called the BIGAM method. Anyway, if you learn this Simplex method, BIGAM method will be easy. And if you understand both BIGAM method and Simplex method, two-phase method will also be easy. It might be time consuming, but they normally ask these questions for 10 marks. So it's worth it, provided you don't make any careless mistakes. And if you don't want to make any careless mistakes, that's clear, you have to practice a lot. Okay, so please write the question, and if you want, you can pause the video and try it yourself, or if you want to make things more clear, you just let the video run and do it along with us. So maximize z equal to 5x1 plus 3x2, and subject to the conditions x1 plus x2 less than or equal to 2, and 5x1 plus 2x2 less than or equal to 10, and 3x1 plus 8x2 less than or equal to 12, x1, x2 greater than or equal to 0, using the Simplex method. So tell me what to do first. Well, now this time I'm going to save a lot of steps. So the first thing you're going to do is you're going to add a slack variable, let's say s1, and then you'll add s2 over here, and then you'll add s3 here. And then you're going to take these things to the other side, so you end up with minus 5x1 minus 3x2 plus z equal to 0. Now let's jump directly to the matrix. So I'm going to write my initial matrix. I told you it's slightly different from the method you see in most of the textbooks, but it will save a lot of time. Trust me, it will save a lot of time in your exam. So let's write x1. So let's count the number of variables. Okay, so only x1, x2. And how many slacks are there? Yeah, so there are 3 slacks over here, S1, S2, S3, and then Z, and then RHS. That's it. I'm going to close that matrix, and we can write ratio outside. Okay, now let's start. So the first one is, can you tell me the first row? Just take a good look at this and tell me the first row. Okay, so that is 1, 1. Yeah, we added 1 and it's nothing, nothing, nothing. And what about the right hand side? Yeah, 2. And then we get, yeah, you can take a look at this. 5, 2, no S1, only S2, no S3. Yeah, okay, I think I can write that. 5, 2, 0, 1, 0, and yeah, 0 of course. And what is the right side? Yeah, 10. And then the last one, that is 3 and 8, 0, 0, 1, 0. What was that right side? I think it is 12. So now let's put the divider and let's go for this. Minus 5, minus 3. So can you write that? Minus 5, minus 3, 0, 0, 0, 1, and 0. Okay. So what's the first thing to do? Yeah, find the most negative thing. And now you take the ratio. So we already have the pivot column. Now the ratio is 2 by 1 and 10 by 5. Oh, 10 by 5, that is 2. And 12 by 3, that is 4. Okay, I'm really happy we did this problem, because in exam, some of you might get stuck. What's the reason? What's the least number? 2. And it has repeated. So you can choose any of these rows. You can choose any of these rows, but I'm going to choose the first row. Can you tell me the reason? Normally, when we find the pivot element, the first thing we do is we make it 1. So that means you have to write the whole table once more. Now look at this. I have to choose between 1 and 5. If I choose this 5, in the next step, I'll have to make it 1. So I'll be wasting one step. So the better option is choosing this. Now what should we do? We have to make all the elements below and above into zeros. So let's write the operations. R2 changes to that. There are 4 rows: R1, R2, R3, R4. And the target is in R2, so R2 changes to R2 minus 5R1, R3 changes to R3 minus 3R1, and R4 changes to R4 plus 5R1. Now you can try this operation yourself. Anyway, I'll copy the answers for you. So I'm going to get, there is no change in R1, so 1, 1, 1, 0, 0, 0, 2. So 1, 1, 1, 0, 0, 0, 2. And then I'm going to get 0 minus 3. I have already done this in a paper. So I hope you're doing the same. And the next one is 0, 5 minus 3, 0, 1, 0, 6. And finally 0, 2, 5, 0, 0, 1, 10. And that's it. Now look at this. I'm going to write, and the good news, it's so awesome because in just one step it became optimal. All are positive. Yeah, and I'm going to write x1, x2, s1, s2, s3 and z. Okay, now look at this. We can see that it's in 3 by 3 format. The 3 by 3 identity matrix is 1 0 0 0 1 0 and 0 0 1. So the columns which we should focus are like 1 0 0. I think I found one. And then I'm looking for 0 1 0. I found that. And then 0 0 1. Now what I do is I find x1, move to Mr. 1, and here I write x1. And similarly here I write s2, and here I'll write s3. Now what? So look at this, x1 is 2. Now no, I don't want this. Look at this. In the question, in the given question, we have x1 and x2. We are trying to solve for x1 and x2. So in the last table, in the optimal table, if you don't get x2 or x1, then just write that is equal to 0. And of course, the optimal value for z is equal to, you can substitute this in the given function, that is 5 into 2, 10 plus 0. Or you can focus on this part and that will be the answer. Now that is pretty easy. Now I'll give you one more question, and that will be the last question in this video, and that is extra important. Because if you get such a question in the exam, you might get confused. Okay, so let's start. So please write the question. Minimize. If you're using British spelling, you can write SC, and if you want the American spelling, you write ZA. So minimize z equal to x1 minus 3x2 plus 3x3, and subject to the constraints 3x1 minus x2 plus 2x3 less than or equal to 7, and 2x1 plus 4x2 greater than or equal to minus 12, and minus 4x1 plus 3x2 plus 8x3 less than or equal to 10, and the non-negative constraints x1, x2, x3 are all positive. So I told you this question is very important, especially if you are not familiar with a lot of questions, or if you have not practiced a lot of questions, and finally in the exam if a question like this comes, you might get confused. I told you in the beginning, in lesson number 5, if you want to apply this method, the method which I am teaching in this video, because book to book it will be different. So the objective function should be maximize. This itself is not in the proper format. So I'm going to rewrite the question. So I'm going to write maximize z star is equal to. So what I do is I'm going to multiply throughout by negative. And instead of this function, I'm going to call it the star function. So we get minus x1 plus 3x2 minus 3x3. I hope you got the point. So basically, if you want to apply the method, it should be in the format maximize. So it's really simple. You just create another function I call the star function, and that is obtained by multiplying throughout by negative. So this becomes negative, this positive, this negative. Okay, and now look at this. This is okay. This is not at all okay. Yeah, this is okay. So I'm not happy with the second condition. In inequations, long back when you learned inequations, maybe in class 11 or maybe class 10, you have learned something. If you have a greater than b or greater than or equal to b, you multiply throughout by negative. The inequation will get reversed. 2 is, let's look at the number line. This is our origin. This is 1, this is 2, this is 3, this is 4. And on this side, minus 1, minus 2, minus 3, minus 4. Now look at this. 2 is smaller than 4. The reason is 2 is on the left side of 4. Now if you multiply throughout by negative, you get the numbers minus 2 and minus 4. Take a look. Yeah, so minus 2 is bigger than minus 4. So what I am trying to convince you is, if you multiply any inequation by negative, it becomes, the inequation symbol will get reversed. So we get, I'll just cut this and write it here. This will become minus 2x1 minus 4x2 less than or equal to 12. Okay, so that's done. That's it. Now you can try this yourself. If you have any confusion while doing the problem, you can contact me from the website www.sjmathtube.com. So I'll give a few hints. When you do that first table, and when you take the ratio, you're going to get -7, -3, and approximately 3.33. So don't get worried about it, just ignore. So this, or rather this element will be the pivot element, and that's something important. And finally your answer will be minus 143 by 5, because from the table you will get positive 143 by 5, but remember that is the answer for Z star. So you have to convert it and make it negative. And x1 is equal to 31 by 5, x2 is equal to 58 by 5, and x3 is equal to 0. So that's it. In the next video we will discuss some other topic. So till then, bye.